So I skipped over the one that had dupe with it. We'll do that at the end. This one is just going to be more of a, I guess you could say, one of the simpler examples, which we'll start out with. And this is just kind of having the message going from a parent to a child, right? So over here, we're saying implement a program that creates a child process and send the message hello to the child process over a pipe. The child must read the message coming from the pipe, print it out, and then terminate. Make sure parent P waits for the child to terminate before printing done and terminating itself. And we're assuming that we got pipe int fd2. Those are going to be our file descriptors. That creates a pipe and returns the two descriptors. fd0 is the read end, fd1 is the write end. Okay, we kind of know that, and you can use wait PID, and we're using the fork system command. Okay, cool. So with that being said, let's just draw this out a little bit first. We're essentially going from a parent and we're sending the message to the child. Hello, right? So we're going to be setting a pipe between these guys. So we can think of this as the pipe, right? And so with this being said, we're going to have the parent write into the pipe. And we know that to write into the pipe, we're going to be using the file descriptor fd1. Right? fd1 is the file descriptor for writing into a pipe. The file descriptor fd0, on the other hand, is going to be what gets read out from the pipe and what gets inputted into C for the child. So we're always going to start out by actually creating the first two, the two file descriptors, right? We can just say that it's just a simple array of integers, right? Int fd2. Since it's just an array of two, right? You have fd0, fd1. And we can use the pipe command to make these guys into a pipe. So pipe fd. Awesome. So we're currently in the parent right now, since we don't have any if statements saying, oh, go to the child or anything. So with that being said, let's actually start by writing in with our fd1 file descriptor to start off with. So since we're, again, not using dupe, we're going to actually use this as the destination register, destination descriptor for the write command. So we're going to say write, the first parameter is going to be fd1. This is saying I'm going to write into my pipe that I just created in the previous instruction. The second one is what I'm writing, right? This is going to be the message hello, right? And then the last parameter is going to be its length, which is a length of 6. So this is going to get passed into my pipe right now. As soon as I pass this in, I'm done with it. I'm not going to pass in any other messages, so at this point I'm going to close the right end of this pipe. So this means this is closed and our message is inside of the pipe right now. Now we're free to pick this up with the child, but we want to also make sure that before we do anything else at the very bottom, we'll have something saying like wait PID. And what are we waiting for? Well, we're going to need to actually define a PID variable. So we can do that over here. We'll use the PID t is equal to PID. All this is just a PID, process ID variable, so to speak. And this will be defined once we fork our child. And we're going to have wait PID at the end of this. So this is going to be the PID, and then our other parameters, null and 0. I was looking up what these actually mean. The 0 is just that you're like waiting for the child that you specify with this PID. There's actually other specificators that you can kind of put here too, but we just use 0 for that, so I kind of just disregarded those. And oh, shit. Okay. So with that being said, we can wait for our PID over there. And over here is where we're going to have our child process. So the child is going to be the one that's reading it. And how do we know that it's the child? Well, we'll just have a simple if statement saying that if our process ID is equal to 0 when we fork. So actually, we haven't gone too far ahead. So if fork is equal to 0, then this proves that this is the child. But we also want to save this process ID into the variable. So we have both an assignment over here as well as a test using the double equal sign. So if you're like me and screwed this up many times, like back in like 111 and 211 and stuff, and you accidentally put one equal sign, this is exactly why, right? This one equal sign is actually assigning the PID for this forked process, this child process, right into here. And these double equal signs are testing if it's 0, so if it's actually the child. So you kind of do two different things in that call right there. Move this guy down a bit. So now what are we doing inside of this child? Well, what we're going to do is we're going to have it read in we're going to have it read in the message. So we first need to set up a character array to hold this, right? Character, message, and this is going to be of 6 length because that's what we're passing in. And then what we can do is we can read that in. So I'm going to read in. Now, just like the write command, right, we have 3 parameters. Where are we coming from in this case is going to be FD0. This is because this is the read in. This is where the message is coming from, right? Then what are we doing with the data? Where are we putting the data? In this case is going to be in the message array, and we just have the length of 6, right? And what we could do is we could also take the length of this to help us with the next part, which will display it into the console. So int length, take the length of that and store it into an integer variable. So the first thing was just an array for my destination. The second, I read the message in for my FD0 from this end of the pipe. So the message is currently inside the child. And we have our length as well, which will help us for the next part. Now, this was not done with the dupe command, meaning that we still do have the descriptors 0 and 1, right? 0 is taking an input from a keyboard or mouse or something. 1 is going to output something to the screen. And what do we want to do? Well, we want to just output the message to the screen. So at this point, what we're going to do is inside of this child, we're going to have our output message, and this is going to write. What are we writing? Well, we're going to just write first our destination. So what descriptor are we using? We're going to use 1 because we want to go to the screen. I'm going to say, what am I doing? I'm going to be outputting in the message, and the length of this is given right here. Okay, so in case, let's say, it has a capacity of 6, but let's say the message ended up being longer or something, this length variable ensures that it can be adjusted accordingly. Okay, so now we've done what we needed to do, and with that being said, what we can do is we could just exit 0, and in the parent, we can close any unnecessary descriptors. So we're done with FD0. So I could close FD0. So just like how we kind of did in the previous example, this is being done outside of this if statement here. So that means that both the parent and not the child too. The child is just exiting, so there's no need to close anything in this regard because it's exiting at this point, so there's no point of closing anything. But we do want to make sure that the parent does, just in case, we end up having to do anything else. we want to close any resources that are not being used. And the reason we close it down here is because if we did it up here at the same time of FD1, then that means when we forked the child, this FD1 and the FD0 would have been closed. So we want to be sure that we don't accidentally have the child inherit a closed pipe. So we have finished with the parent, right? And we have wait PID, so we're waiting for the child to finish. And after this point, we're going to be done. So what's the message that we want to say? Parent done. So after this point, we can assume that this PID that we've waited for, that came all the way up here, is done. So we can just print F done. Okay, and at this point, we can return 0 because this is the end of the program. And this would be this one. So it kind of helps.
I think you forgot to write exit 0. Because don't you need to exit the... Oh,
Is there?
okay.
Yeah.
Wait, don't you write it after though?
What do you mean?
Okay. Oh, okay.
It's,
my bad.
Oh, it's in the if statement here. So this is the if statement.
It's because the brackets to the right of the exit
Yeah,
0.
That's what I was confused by.
Yeah. Put the bracket down there. Make it a little easier to see. Yeah. So we have the parent outside of the box and the child is inside of the box. Okay, does that make sense? Should we do the two-pipe example or the dupe example?
I think the 2-pipe example would be good. Just, oh, I got an email. That might be Akinlar. Give me 1 second.
Yeah, I think the 2-pipe one. Honestly, I have a...
Yep, it's Akinlar.
Oh, all right.
He said dupe 2. Oh, okay. He said dupe 2 is in the exam. Dupe is not. So I guess that's confirmation that we'll get one of the dupe questions for pipe.
Okay. Let's do, all right, maybe we'll do the dupe one then first. Or, you know what?
You said
We're
it's
only
just
gonna
like a
get
typo,
one.
right?
Yeah, what happened?
You said it's just like a typo when he said like dupe. It's
Yeah, that's
like
why.
the name
so
of
that's why.
the function is just
Yeah.
dupe 2.
So dupe 2 will be on the exam, and there's only one coding question. But I'd assume for coding we should focus those.
So is there definitely a dupe question or?
Yeah, he said in all caps, dupe 2 will be on the exam. Dupe will not be in the exam.
Okay, so then let's do this dupe question first. So, the previous example, by the way, if he said that this example, like, oh, you could assume that there is a dupe command or dupe 2 command or whatever, you can absolutely do this with that command as well. It's just a matter of, hey, do you use dupe or do you not use dupe? Both ways are totally fine because both ways can make a pipe. But yeah, let's definitely do this one then. So for this one, right, anytime that we went into to write or to read, I directly said write to FD1, read from FD0, and then like write to 1 to write to the screen. When we're going to do dupe this time, we're going to change where those descriptors tell us to go. So soon, 1 will no longer go to the screen. It's going to go inside the pipe. So instead of using FD1, we're going to be able to use 1. So that's the whole point of dupe. So let's...
I guess before we get into it, could you just explain the parameters for dupe 2?
Yeah, absolutely. So Okay, so we're gonna have three different parameters, two different parameters, and we're gonna be dealing with the essentially changing where the file descriptors are going to. So just to recap, right, we have 0 and 1, right? 0 is just standard input, so going in from the keyboard. 1 is standard output, going out to your screen. You could think of like the console, right? So think of like C in, C out, things like that. Now, when we deal with our file descriptors, right, fd0 and fd1, we could think of it as our pipe. fd1 is the right end of the pipe, meaning that there's going to be a message getting written from fd1 into our pipe. fd0 is the read end of the pipe. This is going to read something out of the pipe. So a message is going to write into the pipe if it's fd1, and it's going to read out of the pipe if it's fd0. So when we do something like dupe2, right, we're saying, okay, what is the descriptor here that we'd like to duplicate here? So you could think of the source and destination.
Sorry, Lauren. In the chat, they're saying they can't see the right side of your screen. Are you able to move the screen a bit over? There we go. Okay, that's good.
Thanks for catching that. Okay, so we have our source and our destination, right? So this first parameter is going to be the source. What exactly are we duplicating? Well, if let's say we want to change 1 from being standard output to the screen to standard output writing to our pipe, we could say fd1 goes to our destination, 1. What this allows us to do is anytime after this, I can say write to 1, hello, and let's just say a length of 6 or something. So what this would let me do is just simply write out to our destination 1, hello. Or even simpler than this, I can just use the print command, printf, and then like a message like hello. Printf leads you to the standard output, but we change the standard output from the screen to go inside the pipe. So instead of printing hello to the screen, it's going to put hello into the pipe. Either way of doing this would be totally valid, by the way. In the program itself, it kind of uses a little bit of both, but we've already, duplicated the functionality of fd1 into destination of the file descriptor 1. So because of that, I can just say, okay, write to 1, and now it goes, boom, right into the pipe. And same thing with reading, right? I could say the opposite. I want to say fd0's functionality, the source, goes into the destination 0. So now instead of reading from something from the keyboard, right? Because then if you would just say to read from 0, that just says wait for some input out of the keyboard. Here, what I'm going to do is I'm going to say, okay, anytime that I call from 0, I read into the pipe. So I can say read 0, and let's just say we had a message gets stored here, and length of 6. So here I'm reading something into this message variable over here, and this is going to be done with the 0, which we've already rerouted that. Instead of going from the keyboard, it's going to go from this end of the pipe. So you're taking the original standard input and output, and you're making it go into the pipe instead. So now anytime that I say, okay, printf hello or read from 0 or something like that, I'm saying, okay, either write to the pipe if I did that dupe command, or read from the pipe if I did this dupe command. Does that make sense? Okay. Let's do this question now with the dupe. So this is going to add in kind of an extra step. Every time before we want to do our writes and our reads, we just have to kind of run the dupe to kind of make that, I guess you could say, kind of semi-permanent connection. So any future can just be used with simple 1 and 0. So let's go through this one now. So assume you want to create 2 child processes, C1 and C2. You want the standard output of C1 to go to the standard output of C2. Okay, so let's say first, I always want to draw a picture. We have our parent, and it's going to fork 2 children, C1 and C2. The standard output of C1 is going to go to the standard input of C2. So we're going to have a pipe over here, right? Write a very simple code to create child processes C1, C2 and tie them up using a pipe. C1 will send the message hello to its standard output, which C2 will read from its standard input and then print it to the screen. Okay, so let me just say that goes to the screen. And after both children terminate, the parent prints parent done on the screen and terminates. So let's see, what are we assuming? We have pipe int fd2 creates the pipe, fd0 is the read end, fd1 is the write end, and we're going to assume the existence of dupe2. So this is our key that tells us we're going to use the dupe command, not just do it the other way around. This makes what fd2 is the same as fd1, so that's saying whatever is in this becomes in this. Basically just what I said before. And use the fork system to call the child process. Okay. So we want to create our pipes, file descriptors and pipes first. So let's say fd int fd2. We want to pipe that. And now, unlike the last time, the parent's not going to output anything, right? The parent is going to just wait its turn till the end of this part, right? So we're going to go right into the child. So because these 2 guys are making a pipe together, I actually only have to wait for one of them to finish, because the other one is going to not be able to finish until the other one finishes, right? Because this one's going to be writing in and this one's going to be reading out. So if I say, hey, just wait for C2 to finish, well, C2 needs a message to come from C1. And if I say wait for C1 to finish, well, C2 is going to read something in and has to wait for C1 to send a message, and vice versa. So with that being said, let's start out by forking our child. So if fork is equal to 0, that means we're dealing with C1 in this case. So this is going to be our C1. Okay, so before we do anything, right, we want to use the dupe command to get the pipes the exact way we want. So C1 is going to write a message. That means this is the FD1, the right side of the pipe. C2 is going to read, so this is FD0, the read side of the pipe. So if I'm dealing with C1, this is saying, okay, I want to take FD1 and put it into file descriptor 1 so that I can just print something using like a print message, and it goes through the pipe instead of to the screen. So I'm going to do dupe to source FD1 destination 1. Boom. Now I'm good to go anytime that I want to call. Anytime I want to write to the pipe, I can just use the system descriptor 1. Now, anytime that we yeah. Sorry.
Just to confirm, we're taking the standard output of C1 and putting it into the standard input of C2, correct?
Yes. Standard output of C1 to go to the standard
Okay.
input of C2.
Okay, yeah, I understand it now. Thank you.
Yeah. So it always helps me to draw like a little picture out. So we're writing into the pipe because this is outputting out of C1, goes through the pipe, and then goes into C2.
Yep.
So anytime that we run the dupe command, now everything that FD1 can do, the file descriptor 1 can do. So FD1 is pretty useless at this point. So at this point, we're going to close it. Oops, FD1. Now we also want to close anything that we're not using. C1 is not listening to anything. It's not going to accept any messages from the parent. So we could think that it's closing its ears, right? So we're going to also close its ability to read from the pipe too. There's only so many resources that can get allocated. So if you're not going to use it, you want to close it immediately. So anytime that you dupe something, close it. Anytime that you use something and you're done with it, close it. If you're not even using it in the first place, close it. I kind of like to make a little list in the corner and just be like, okay, what is this using? Okay, well, I need FD1 to start. And then that gets converted into 1. So close that. And FD0 wasn't used in the first place, so close that. So now that we're good with
So
that,
we're able to close. We're able to close FD1 because it's been copied into 1. So there's 2 versions of it, and so we no longer need FD1, and that's why it's closed.
Exactly. Yep.
Okay.
So we close things after we duplicate them, and we close things if we didn't use them in the first place, and we close things when we're done with them. So 3 things to kind of keep in mind. So close when, after dupe, after you finish it. So after, let's say you finish sending a message, then close. Or exit 0. Either is fine. Or you can close, or if you're not using it in the first place. Right, so C1 has nothing inputting it. It's only outputting. If, let's say, it was inputting something from the parent, or in the case when we have 2 pipes, which we'll deal with in a little bit too, then we would need to keep it open. So we close FD1. Since we duplicated it, everything can be used with 1. There's no need for 2 file descriptors that have the same purpose. We close FD0 because we didn't even use it in the first place. I believe you could probably even have done it over here too, because there's no need for it in the first place. You can't do it in the parent just yet, because then it would take into effect for all children, and C2 is still going to need it. But at this point, we can't exit yet. At this point, right, we're all good to go. So we can do our write into the pipe. Again, we can do this 2 ways. We can use print now if we wanted to, which is kind of the easier way of doing it. Or if you wanted to, you could also do write into file descriptor 1, and you can do your message, hello, and then the length of 6. So either of these work because both of them are saying, okay, put this into descriptor 1, put this in, print this out to the standard output, which is descriptor 1. So now that we printed, child 1 did everything it was supposed to. It changed where the pipes were heading, it closed unnecessary pipes, it wrote through to the pipe, and now we're good to close. So exit 0, and this is the end of child 1. Okay. So now, at this point, we're back in the parent. And before we go into child 2, we need to just double check. Do we close anything? Okay, well, I didn't do a dupe. And I just finished reading things into a pipe. So that's my sign in the parent as well. Close FD1. Right? We don't have to worry about creating a new child 2 that has this closed in the first place because it's closed in the parent. So all children will also have this closed, which is not a problem because the only child we have to create is C2, and C2 never writes anything into the pipe. So there's no need to have FD1 open. So now that we did that, we're actually good to create our second child. We still do need to have the parent wait on at least one of the children. So we can do this for the second child, right? We can create a process ID variable here. And this one will be set into our next if statement. So if, do our assignment, process ID is equal to whatever fork is equal to. And we test if it's 0, if it's the child at the same time as well. So this is going to be our child 2. So child 2 currently has FD1 closed from the parent, which, okay, that's great. One less thing that we have to worry about because we would have to close it anyway. Here now, we want to start out by duping, this time, the read, so that anytime that we get a standard input, it comes from the pipe only. We can use our dupe 2, once again, source and destination. Source, functionality of FD0, and put it into descriptor 0. Now, anytime that we read something from the pipe, and put it into C2, we could also use 0, just like how we did 1 over here for writing. So now that we duped, right, we want to close after we do a dupe. We're going to close FD0. So FD0 is also closed for this guy. Now we're free to actually do our read. So just like before, we're going to create a little message as a character array. We can have a length of 6 because again, we're just doing hello. And we're going to read in. This time, we're free to read in from file descriptor 0. The last question I did, I had to say that this was FD0. Now, I can just say 0. I read 0. Where am I reading it to? Well, I'm reading it into the message variable, and its length is 6. Right? And I can also keep track of its length by having my int len variable here. Okay. So now that we have that all good, right now that message is saved into the message. So what do we want to do with this message? Well, we want to put hello to its standard output. Something key to keep in mind is, in the previous example, we permanently changed the standard descriptor 1, or anytime we said print, to go written into the pipe. But because this is the child, this was done in a unique process. So now, anytime we do something in this child, 1 is still pointing to the screen. The only difference is the read, 0, it comes from the pipe now. So I can now use either printf, right, just like we did before, or I can do a write into file descriptor 1. What am I writing? Well, I'm writing my message, and what's its length? Well, we made a length variable for that. And at this point, we wrote it to the screen. There's nothing open that needs to be closed. Child 2 did its job. Child 2 can exit 0, and child 2 is dead now. Well, zombie now. Now, what was the parent doing while all this was happening? Well, we wanted to make sure that it was going to wait for this process to finish, right? Now, the parent is going to wait PID this process ID comes from the one over here. Does the parent need to close anything? Well, the only thing that was closed on the parent was FD1. So let's honestly make sure that FD0 gets closed as well. Close that. And does it say that we need to do anything else? Print that it's done, right? So once again, just keep in mind, we only manipulated what 1 points to in C1. So that means, once again, in C2 and in the parent, we're free to still use either print or the write command here. And return 0, since now we are done.
Makes sense to me now.
Yeah, that's great.
Would it be wrong if you put closed FD of 0 before wait PID?
Technically, it wouldn't. Just
Alright.
because it's like, even though you're doing it before waiting, you're still in a separate process.
Oh, okay.
Yeah, so
I know it looks like it would be incorrect, but it's still correct.
yeah, exactly, because we forked like beforehand, so that process was made before like we went into that bottom part of the code, right? So over here, C2 was already created. So honestly, anywhere at this point, we can close FD. So honestly, it's best to do it as early as possible. So you could honestly put it right there. As soon as you no longer need it, which is, when do we no longer need it? After C2. Just close it immediately. So close after you
Yeah, I
did
think
something.
in his actual answer, he closed it before the wait PID too.
Yeah, he did.
But either one works.
Yeah. He did that right over there.
Yeah. Just know that, like, on the exam, for everything that you don't close, you will get off points. So make sure to close your stuff, like, in every process that you're in. It's like whenever, anytime you fork, before you finish, make sure everything's closed up, and then go. Like, for example, in the first if statement, you see how Lauren put close FD1 and FD0, and then she exited. Same thing with C2, but except for C2, FD1 was already closed, so we only need to close FD0. So just make sure everything's closed up.
Yeah, honestly, I recommend keeping track of everything that's open for every process and just kind of checking off like, hey, after you do a dupe, close it immediately. After you finish or exit 0, close it immediately if you're no longer using it. And if you're never going to even use it, close it immediately. Just kind of put those 3 things into your head, and as you're going along, just kind of check it off. Like, hey, is something open? Do I need it again? Nope, close it. I think that's probably the most difficult part, like trying to figure out like when to close things.
Mm-hmm.
I have a question about the close. Like, let's say you just do close of FD. Is that just closing the whole pipe, or like not like indexing anything?
I think you'd have to put an index
Sorry,
in.
what did you say?
Like what's the difference like with if you just close of FD, like not indexing any part of the array?
Just say close FD.
Yeah.
I don't think you can do that. Because remember, FD1 and FD0, they contain integers. Close takes an integer, you can't pass in an array.
Yeah, because close
Like-
is a
like-
function.
Yeah. It passes in that number and it knows exactly which address to go to based on that number, so it can't take it in an array.
I was asking because I saw in his number 9 answer he did that in one of the lines. Maybe that was a typo, I'm not sure.
Number 9, can you go to number 9 real quick?
Oh, hang on a second.
Oh yeah, it's there, I saw it. FD2.
Sorry,
Well, that's...
Nine. Oh, here we go.
Yeah, if you go down, it shows it. Right there. Yeah, so... Oh wait, go down more. Oh wait,
The third close.
where is it? Yeah, you see there, it says int FD is equal to open. It's an integer. The FD was reassigned to something else, and then it was
okay.
closed.
Oh, okay.
Yeah, so that's saying close
That
that
only
FF
takes an
parent
integer.
text file. Okay. Okay. Oh, this was the one we just did, right? Yeah. All right, let's do the 2 child processes with the 2 pipes, since this one's a little on the confusing side as well. Okay, so
Alright, which one are you doing?
number 6.
Okay.
Yeah. So this one, we're creating our 2 child processes, right? And this is C1, this is C2. Now this time the parent is sending a message to C1. And then the message is going to get sent from C1 to C2. So there's going to be 2 pipes this time. So we can think of this as having a pipe here and having a pipe here. So the best way to kind of think of this is just to draw it out as well. So I'm going to draw this one out here to C1, and then draw one out here to C2. So we're going to have 2 pipes this time. So we could start out by doing int fd1. Oh, sorry, fd2. fd1, 2. So this is saying this is pipe 1, and this is also 2 descriptors, right? We can pipe this. And then we could also have our second pipe as well, right? So then that would be int fd2, 2, pipe fd2, yeah. So this is going to be pipe 1, and this is going to be pipe 2. So P is going to write into pipe 1. So that means fd1 with a file descriptor of 1. So in the first pipe, I'm going to do a write. This is going to be the write end from the parent writing into this pipe. Child 1 is going to read this out of fd1 with a file descriptor of 0, since this is the read end of the first pipe. Now C1 is going to write into this end of the pipe. This is going to be pipe 2, file descriptor 1, since we're writing into the second pipe. C2 is going to read this. So we're going to read from FD pipe 2 with a file descriptor of 0 to show we are reading this. So this is how we're going to do this one. So it always kind of helps me, because otherwise it's like, okay, I have this pipe and that pipe, too much going on. So the first step is, while we're in the parent, right, we're just going to do a simple write. So question, are we doing dupes or no dupes? No dupes here, right? Yeah, no. So this one does not have dupe in the question. That's how we know that we're not using dupes. So we are going to actually call the file descriptors by their names. If this was dupe, it would be getting very hairy, honestly. So I'm kind of glad for that. All right. So we're good to start writing into our parent, right? So writing into this pipe. So we're in the parent right now, and I can just call write. I can't use printf because that would print it to the screen since we didn't do any dupes to modify that. So I'm going to write. Where am I writing? Well, I'm going to write into pipe fd1. fd1 with a file descriptor of 1. What am I writing? I'm writing the message hello, and that has a length of 6, right? Now, after I do this, parent is no longer going to be writing. So what do I keep in mind? I'm not going to use file descriptor 1 anymore. Then I'm done. Now, you're probably also thinking, but wait, aren't we going to write again when it comes to child 1? This is a completely different pipe. So each of these pipes has a read end and a write end. A write end and a read end, right? What you're writing into and what you're reading from. And this one has its own end of where it's writing into and where it's reading from. So if I close this pipe, that's no problem because this one is still open. So I'm going to just close fd1 with a file descriptor of 1. So this guy over here is closed. now at this point, right, we are good with the parent, right? We have our two pipes, we wrote our message, awesome. So now we want to also make sure that the parent P waits for all children to terminate before printing. So like last time, we only really need to wait for one parent to terminate. I mean, one child to terminate, because the pipe kind of shows like, hey, one child is still running and waiting for something else. So until it gets that something else, it's gonna still be waiting for the other child process. So all that means is I can just pick and choose which one I want to wait for. So we could just do the second one to wait for. So I'm gonna go now to my first child process. So we're gonna have if fork is equal to 0, this is going to be child 1. So what is our child 1 doing? Well, I don't have to dupe, so don't have to do that first. That's my first thing. All I'm doing is reading in from FD1. So just like last time, we're going to well, actually, should we close anything first? Let me just write this out first and then I'll close. I'm just trying not to look at the answer. So we got character, message, the length of 6. We're going to do the same process as before. Int len is equal to reading from, okay, where are we reading from? FD pipe 1, file descriptor 0, right? This is where we're reading from. And we're going to read in to message with a length of 6. Okay. Now at this point, FD1, 0 is done. I can close this one right here. Now this is only closed within the child process, so we have to keep that in mind when we close it for the parent as well. So close FD1, 0. We're no longer reading anything in. Now, what else do we have to keep in mind? Well, we're going to have to write this guy. We're going to be writing it into FD2, 1. But this process C1 will never be using FD2, 0. Why would it bother using this when this file descriptor for this pipe is only used to read into C2? So I can close it immediately at the very beginning. So it really helps kind of writing out exactly what is open and closed, right? FD1, 1 is closed for everybody. I just closed FD1, 0 for this guy. And I'm going to also close FD2, 0 as well. So this guy is not listening to anybody anymore. He's not reading from anybody. Right? Just double check. We're all good with that. Okay. Awesome. Okay. And oh, wait, now we have to write. Okay. So what is this guy doing? Well, he's going to write into this pipe over here. I could just do simply write into, where's my destination? I'm writing into pipe 2 now with a file descriptor of 1 to show I'm writing. I'm going to write in my message with a length of len. Now I'm good to exit 0. All right, child 2 is child 1. Geez, feels like it's been 2. This guy is all done. Okay. Now we're back in the parent, right? So we exited here. So once we exit, like everything also closes, so we don't really need to worry too much about that. But we also want to make sure that the parent itself, right, because we're back in the parent at this point, closes anything that we're never going to use again. All right, well, at this point, we made it here and here. So we are actually done with FD10 and FD21. So we're going to close these guys in the parent so that they're closed permanently for any child. Right? There's no point in making a child that's never going to use them. Just like C1 was never going to use FD sub 1, there's no point for child 2 to use these two guys over here. So I'm going to close FD 1, 0 and close FD 2, 1. Right now, this means the only guy that's open is the read end of this second pipe. And we're going to be using that when it comes to C2. Now, we do need to make sure that we actually do wait for someone. So C2 is the process we'll wait for. So we're going to set up, before we go into C2, a process ID variable. And this guy is going to go into this instance of forking. If PID is equal to, set it equal to whatever fork is equal to, and test A, is this the child? So this is our C2 process. Okay, we're not dealing with dupe, so we don't have to worry about that. And at this point, what is this guy doing? Well, he's reading from FD2, 0. Nothing else is open, so I don't have to worry about closing anything. So I'm going to go straight into reading this guy. So just like last time, I'm going to do literally the same exact thing. Car message 6 int len is equal to read from, where am I reading from? FD2, file descriptor 0. Okay, and I'm reading it into message with a length of 6. Awesome. And what am I doing with this now that it's in the message variable? I'm pretty sure it's going to the output. Yes, and simply puts it to the screen. Cool. So at this point, now, before I even go there, I finished reading from FD2, 0. I'm going to close it because I'm not using this again. All I need to do at this point is write this to the screen and then I'm good. So I'm going to close FD2, 0. And now I'm good to write our message to our standard output. Oops, so not quotes, it's variable message, and it has a length of length. Okay, all of the guys are, all of the pipes endings are closed in this instance of C2. Right, this was the only one that was left open. Now it's closed. This was all done, so I should be good to exit 0 at this point and end that process. Okay. So now, before we go on to the next part, okay, awesome, that looks good. Now we're back in the parent, right? This is once again in our parent. So what is the parent doing? Well, we need to make sure that it actually waited for this process. we want to wait PID, and I'm waiting for the process ID given up here. Right, and before then, I want the parent to finally close the last one that was left open. Right, we closed it in the child, we want to close in the parent so that it's closed for good. Any future children, the pipe is gone. So we're going to close FD2 0. Okay. We wait PID. I think we system out, we print that it's done and return 0, right? Okay, and that's the end of that problem. Okay, questions? That was a bit of a long one. Are you guys still alive?
Yeah.
Good to know.
Yeah, I think this one's a good one. I think honestly, if we want, we can make our own too. Like if you want, after you finish the pipes, I'd be down to go through an example because I do want to study it as well. The what's it called with Dupe 2, we could maybe do a similar Dupe 2 thing, but instead with 2-child processes. I could try that out once you're done going over pipes.
That's a good one to do, yeah.
I guess if you want, do you want to run over like exec v, and then if you want after that, I can go over that.
Yeah, so this one I think is a good one to do since this one has both dupe and exec v in it. Exec L in this case.
Mm-hmm.
I did want to go over the ones that had the files in it because I did not have the chance to do 8, 9, basically these guys. So these guys I haven't had the chance to do. So, honestly, he said that it could be any of these, but most likely one with dupe. So I'm honestly down to do the rest of these guys with you guys. Or if you want to trade off Justin as well, we could totally, do that.
Yeah.
Right, cool. Did you want to do this one, or?
You can do it if you want the XFV, because I haven't worked with XFV yet. So I just want to see how it works first. I just have to see it first, and then I should be able to understand it.
Okay, awesome. Yeah, I think that's like the last.
It looks pretty simple. I just need to understand the parameters, and then I'm fine.
Yeah, I gotcha. All right, this one, we're writing a simple code that forks 2 child processes, bin ls and bin wc, right? So just as Justin said before, bin ls, right, you're listing out all the processes. Bin wc is just a word count, and connects the standard output of bin ls to the standard input of bin wc using a pipe. So let's just write that out really quick. It's going to say ls, do a script L. All right, it's a little different. And WC. So the standard output of bin ls is going to go through a pipe and go into WC. So we got ourselves a nice little pipe here. It's just these 2 processes to keep in mind. And also these guys are forked from a parent. So this is going to involve both forking this from the original parent and then using exec v or exec l. Both are the same pretty much, just depends on the system. And you're able to overwrite the parent with either ls or wc. So if this is our pipe, we know that FD1 is the write end and FD0 is the read end. So we always want to draw our picture first, that way we know exactly which one is which. All right, and then waits for the both processes to terminate. All right, don't have to worry too much about that since, again, they're connected with the pipe. And then finally prints my program exiting on the screen. Okay, so my program exiting is going to come from the parent. Whatever that message would be. Okay. And we're going to assume here, important, that we have dupe 2. Okay. So just like last time, we're always going to start out by creating int fd2. And we're going to pipe it. A little bit better now that we only have one pipe to worry about. But maybe we'll do another one later that has more. Okay. So we want to fork this guy immediately. So let's go if fork is equal to 0. This is going to be a child process. So let's set up our pipe first before we exec over. So let's set up the pipe dupe 2, source and destination. By source, I want to write into this pipe fd1, and I'm going to have the destination be 1. And now that these guys are basically a clone of each other, I'm closing fd1. Let me also think, is this guy, our list processed, ever going to use fd0, the other end? Nope, close it too. So now that that's all done, right, unlike the last one, we're not actually going to be writing anything to the screen. We're just going to have the standard output, which, okay, here we go. Great example. BinLS is going to have a standard output. It's going to output to the console. Whatever gets outputted to the console this time is getting rerouted into the pipe. So at this point, we don't need to write anything. We just need to exec it so that the process of BinLS just overrides into this process here. So we can do exec L, since that's the one that he did there. Exec L and exec V are both good. Did it say the command to use? All right. Well, if that's the case, honestly, I think either is fine to use them. So this one is always a little bit confusing to remember, but what I think of it as, you have the entire process, in quotes, right? So bin ls, think of it, it's like the full name of the child, right? Then you could think of it as almost like its nickname, or just the sub part of it. So from bin, you're calling the command ls. And then this part is null. I looked up why it was. I forgot exactly what the reasoning was, but I think it's just an extra parameter that, like, if you want to have it ran a certain way, but we don't use that. So really just know full command, and then the part of that.
The last part of it.
Yeah, exactly.
Basically, I think. And then I think after that, you just write like any extra parameters it might have. But I guess in this case, it doesn't take any. So it's fine.
Yeah. So interesting enough, we don't have an exit 0 here, because this part, if anything was over here, nothing would execute here unless there was an error happening there. So because of that, we're not going to have anything after that. And all of our pipes are closed here, so we don't have to worry about any extra resources that are not being taken care of. So now that we're back in the parent process, Before we end up creating our second child, we want to just do a couple of things, a couple of housekeeping rules, I guess. We closed FD1 and FD0 in the child, but the child is going to need FD0, child 2. It will not need FD1. So the parent has permission to close FD1. Now we can do our process for waiting, right? And proceed to fork the second child. And this one will be for WC. So if I want to say it's PID is equal to fork test if it's the child. Okay, same process, right? We want to dupe 2. This time FD1, FD0. This is going to go into the standard input now, right? Because we wanted this to go into the standard input, anything read from the pipe. Now this guy is obsolete. I can close him. There's no need to close FD1. It was closed in the parent over here, and that was inherited by this child. Now I'm free to exec the process. Exec L. What is the full name of the process? Bin WC, and the ends part WC and null. Boom. Done. All right, back to parent. Do I need to do any cleanup? This guy was completely closed over there. Now I gotta close this dude. Close FD0. And now I am good to wait. PID. Put in my PID. Null 0. And what am I supposed to print here? My program exiting. So print my message, whatever the message is. Don't really care. And return 0. And that's pretty much exec L. So that one's actually even easier, honestly. Like all you do is just have that, and that's it.
I'm a bit confused. Word count, like when you execute that, are you like supposed to like type into your keyboard and then press enter and that gets sent to FD0, or like?
Oh, that's a good question. So binls, right? It runs this command, and the output of this command, so all of your processes get sent into word count. So it word counts all these processes. So it gets sent automatically through the pipe. So whatever this output was, which again, it runs, and we know it outputs because it outputs to the console, that gets put in as input to the word count. So the word count is going to do a word count on all of this.
So basically, what's read from the pipe is being fed into the keyboard descriptor, so 0, that's the standard input, and then bin word count just takes what's in that descriptor and then runs the function on that. I guess that's what's happening.
Exactly, yeah, because we did the dupe2 command. So the input for bin WC is coming from whatever was given to us in the pipe, which came from ls.
And FD0.
Yeah.
Gotcha. That came from ls because we assigned the writing of the pipe to be the standard output.
Exactly, over here.
Okay.
So whatever I put
Makes
into
sense.
ls goes through the pipe and goes directly into WC.
Gotcha.
So why is there's no exit zero in if statements again?
So we exec L. This says stop this program. Let's just say this is the child one. It overwrites this whole program with bin ls. So it stops the program at this point. And it'll exec this over it. So anything after this exec in this if statement would actually never happen. So in the example we did before a while back, we kind of showed that we were supposed to change the variable after an exec, but that would never happen because the program gets ended here and switches over to bin ls. So this program here already has its own exit zero and its own, like, it has everything it needs. So we don't need to worry about any exit zeros. We do all of our closes and everything beforehand. So this is like almost like you terminate it by having another program overwrite what you forked, if that makes sense.
Got it. Thank you so much.
Yeah, no problem. So the key thing to remember, the difference between this is exec is the end of the program, the child at least, because you put a new program directly on top of it. Think exec end EE. Alright, this next one here, 8 does not have a, 8 has, like where you have to open a file. This one I haven't done before, so this one will be new to me as well.
Did you even teach about opening files?
Not really, honestly.
I don't think he did, right?
No. I think he mentioned it once, but like not actually opening the file.
Honestly, I doubt that would be on it, but we can do it.
Yeah, honestly, I don't want to take chances, but yeah. I'm gonna actually just pause the recording here and just make a new one, just because like it's been going on for a while and like I don't really want to have it crash in the middle.
Yeah.